where I would like to talk basically about two people, or two streams if you want to. The one is Chris Langton with artificial life research, and the other one is John Holland. They are very much in line with each other, but nevertheless these are two names that I would like to mention at least. Artificial life research is the research that took as an assumption that if it appears to be impossible to take a very complex system and reduce it to a simple system, and that clearly is impossible, then the question becomes, would it be possible to take very simple elements, autonomous agents, recall what I said about the mind, autonomous agents that interact with each other and create something complex. 22 soccer players that are very simple people, and they do all very simple things. However, the game of soccer as you see it before you cannot be programmed by a straightforward computing program, since it is too complex, literally, nonlinear and dynamic. However, each individual agent player does very simple things. At least he knows what he is doing. You can describe what every soccer player does. But the game emerges out of interaction of those simple actions. Now, that is the essence of artificial life research. Can you create complex systems? A soccer game? I don't say it's important, but at least it's complex by definition, right? Can you create a complex system starting from a simple interaction of simple elements? And indeed you can. And that is the whole stream of artificial research. You have these famous examples of the flock of birds, right, where you only have two rules. Each bird remains between 15 or 25 centimeters from all the neighboring birds, and if every bird does that, the whole thing nicely goes, complex, but smoothly in one direction. The same is true with a bee colony. You can simulate a bee colony giving autonomous behavior to each of the bees and give it 3 or 4 rules. Right? And each bee individually adapt those 4 rules, which are very simple. Go for food. If you go for food, follow the trail back to the nest, etc. I mean, very simple things. But if you do that with those 1,000 bees, you get incredibly complex behavior simulated. Right? It's very much based on animal behavior, biological behavior, if you want to. In those very remarkable in those bee colonies and in those people colonies, since of course it's all the same, is the concept of self-organization. There is a queen in the bee colony, but the queen is not an authority. The queen does not give the rules. Each bee is autonomous and does what it needs to do, not what it wants to do, what it needs to do. Every cell in the body is autonomous, and every cell knows what it needs to do to the next cell, but it doesn't know that there is a third cell behind. So every cell does precisely what it needs to do in order to function in the network of cells without knowing the bigger frame. The same is true in a bee colony, the same can be true in a company. So as long as every agent knows what he needs to do and does that in interaction, that is crucial. So not in hierarchy, not there's a smart guy who says you should do that. That doesn't work. But if you put 10 people together and they know each individually what they have to do in order to optimize their behavior, the whole thing will automatically self-organize itself and produce complex behavior. Now that is a very interesting development that you can simulate in computers. To start with, so that allows you to do very down-to-earth research on emergence and all these kind of things, right? One of the best-known developments that comes out of that line of research on artificial life is interacting, possibly negotiating agents. So you simulate, an agent is a computer program. You have all these type of computer programs that start. E-business today is very often nothing more than a number of agents, software programs that negotiate with each other. There's no individual, no person involved anymore. The whole negotiation goes automatically. That is a huge part of the business-to-business e-business market today, which we don't see as individuals. Of course, it's not business to consumer, it's business to business, but it's completely by agents, right? So in a few years from here, in your PDA or in your phone, you will have a software that I think I gave the example that you go and buy a hi-fi installation. You go physically into a shop, you choose what you want to, you read the barcode with your barcode reader that will be in your phone, right? And your agent that is in your phone is going to go on the network and is going to say, hey, where else do they sell this thing at a cheaper price, for instance, or with a better service? And the thing is going to negotiate with the software agents of those companies. This is no science fiction, this exists. I mean, there are companies that have it. It's a question of, is it commercially viable? But technically it is viable. There's no problem with that. So it's going to negotiate, comes back after a minute, says, hey, there is one for 80% of the price, 200 meters down the road. But the agent of the shop where you are knows that you're there, since in your PDA there is also a GPS, so it knows exactly. It says, hey, just a minute, before you leave, I'll give you a 20% reduction. You buy, you don't buy, right? That is an existing application of negotiating agents, and as I said, which you see a lot in B2B e-business today, right? And the whole simulation, the simulation on artificial life, you have many simulations on the internet. The whole issue is that you have loads of agents, loads of individuals, loads of people, loads of cells, and they all undergo the same 1, 2, 3, 4 rules, each simulation. And remarkably, if you see to those pictures, they either create order, they can create chaos, they can first create order, then code to chaos. There are remarkable patterns that come out that you cannot anticipate. Right? There's a whole book written on artificial communities, where they do lots of simulations on how people, so they simulate artificially people, for instance, why they're going to create war about food. And the more the food goes to one community, how the other community is going to automatically oppose and eventually gets to war. It's very exciting. It's a book of Axelrod, I think is the name of the guy. It's very interesting to see what you can do today with agents. And I'll give a few examples, since I've done myself quite a lot of research on using agents and neural networks. So, if I go now to John Holland, who is a little bit less into artificial life research, but more into artificial intelligence, however, in the same line of self-organization, agent-based, most people will declare John Holland as the godfather of agent-based simulations. And agent-based simulations is where, for instance, if you would use an agent-based simulation, which some of my students, my PhD students, have done around innovation, then you would look into new product development teams. You see there are 10 people involved. You give to each agent, each person, a number of qualities, and you define interaction rules. So the essence of agents is you have simple agents that all try to maximize what they need to maximize. In the soccer game, everybody wants to make a goal. That's the only goal of the game, make a goal, 11 in that direction, 11 in that direction, but it's exactly the same goal. So every agent is going to optimize his or her goal. And you have simple interaction rules. So there are 3 things for an agent. You have to define the field. You play soccer and no basketball. It's almost evident, but nevertheless, this is the field within which we play. What is the aim that each agent wants to optimize? Learning, knowledge development, highest profit, whatever. And then, how do we interact? How do we exchange information and knowledge? And once you've defined that, push on a button, and the whole exchange process, right, of information, etc., is going on automatically. And you see, for instance, going back to new product development teams,